On today's mathematics, we will look at solving multi-step equations. In today's lesson, we will look at how to solve multi-step equations and consider some different circumstances and cases that arise when there's more than one variable. Now again, no matter how many steps, the inverse order of operations is how we solve these problems. We always want to try to apply our SAD-MEG concepts. Work by looking at what's happening to the variable and undoing in the inverse order of operations. Well, let's consider our first example. Here in number 1, we have 2x minus 5x equal to negative 18, and this is something we have not encountered yet. How do we work with something with two variables? Well, quite simply, there's just work to be done before we start solving. Notice we have like terms. 2x and negative 5x simply need to be combined, right? Because they share the same variable and exponent combination. Take that 2x, subtract 5x, and we're left with negative 3x equal to negative 18. From here, we have a one-step solve left. We know what to do from this. X is being multiplied by negative 3, so undo the multiplication by dividing both sides by negative 3, and the result, of course, is x equal to 6. So you try one. Try number 2 on your page. After combining like terms, undoing the addition by subtracting the 8 from both sides, and then undoing the multiplication by dividing both sides by 9, we can find that x is equal to 0. Let's look at another one. This one involves some distribution. Now in the past, we talked about looking at that negative 7 as a multiplier by the group, but now that we have more than one place where a variable lives, we're going to want to distribute this first. Take the negative 7, multiply by the 8x, take the negative 7 times the negative 8, remembering that a negative times a negative will yield a positive. The distributed piece would be negative 56x plus 56 minus the original 8x, all equal to 440. If we now combine our like terms, negative 56x minus 8x, that's negative 64x, plus 56 is 440. From here we have a simple two-step solve. Right? Subtract the 56 from both sides, undo that addition, then undo the multiplication by dividing both sides by negative 64, and we can find that x is negative 6. So you try one. Distribute first, combine your like terms, but what happened? Uh-oh. The x just disappeared. This is a very interesting and occasionally will happen case where you end up losing your variables entirely. Because the resulting statement is a true one, in this case, right, negative 35 does equal negative 35. The solution to this equation is actually known as all real numbers. Any value would make the original equation true. You could substitute any number in and it would work. So because the result was true, we can say that all real numbers would satisfy this equation. All right, what about double distribution? Well, just like it would look, we should distribute each group. So take the negative 6, multiply that by x, then by negative 3. Take the negative 1, multiply by 4x and negative 8. Again, remembering negatives times negative yield positives. So negative 6x plus 18 minus 4x plus 8 all would equal 56. Go through and combine your like terms, and the result, negative 10x plus 26, being equal to 56, is a two-step solve. We can undo the addition by subtracting 26 from both sides, and we can undo the multiplication by dividing both sides by negative 10. The result, of course, then, is that x is negative 3. So one last time, give this one a try. Distribute through, combine your like terms, and in this case, the x disappeared again. But now, the result is not a true statement, right? Negative 57 does not equal negative 5. And so the solution here is actually no solution at all. There's no number that would work that would make this true. So our special case is if the x disappears and a true statement is left, all real numbers work. But if x disappears and the statement that results is false, the answer is no solution. So much like the rest of our solving skills, we want to simplify, use our SADMEG, and undo through inverse order of operations to solve and find the missing variable. For homework tonight, try the odd problems on the attached multi-step solving practice worksheet.